Okay, I thought I'd have a go at building this component tester. That's the word I was trying to look for. And in typical Chinese fashion, there are no written on paper instructions. So I've got two choices. I either do it by feel and guesswork, or I look it up, and at this time of the morning, 20 to 5 AM, I think I'm going to go by feel and guesswork, because I really just can't be bothered to fire up the laptop right now. So I'm just sorting out the components and looking at what bits and pieces we need. Now, just looking at that looks like it's, yeah, so I think I've got a rough idea of where to put things and what I'm going to need to do. So rather than just waffle, I think I'll get on with it. Do I make this a silent video and a step through? Probably. Let me just open this board up, and I already noticed that let's see if I can get it to focus in for you. There's already 3 surface mount components soldered on, so they don't expect you to do that part of it. There you go, that's a better view of it. So the board is pretty well set up. So I think what I'm going to do is, as I say, I'm just going to come back down to table level, and I'll work on it using the inbuilt screen prints, and just generally go through as I normally would on a kit build. So without too much more waffling, let me carry on and see how we get on. Let's put that to one side, that to one side. Start with the resistors as usual. They are the smallest components. Let's see what values I've got here. Right, okay, seeing as we've finally put the transistor component tester thing together, and I thought I'd go through some of the basic functions of the of the device. Now it can test resistors and capacitors, and I have here a selection of salvaged components. I'm just straightening the leads on a resistor at the moment so that it will fit in the socket. There we go, and here we go. So right, what we have here is just a straightforward resistor, and I'm going connected in the socket like so, and put that out there, and push the button to start the test. And it's detected that it's a single resistor, and it says it's 228.2 K, which when you look at the colour coding is pretty close for what it is. So for an old resistor, yep, I'd say that was a pretty accurate test. So that's a resistor. This is an old polystyrene capacitor, and it says on the side 1800 picofarads. So again, we'll put this into the required slots, put the lever down and press the button again. Is it going to do anything, or do I have to reset it yet? Right, it's going to tell me that there's nothing in there. So okay, so let's put it in and then hit the button. There we are, 1762 picofarads, which seeing as it's only 37 picofarads off, well within the 5% tolerance of the capacitor. Again, I have a large resistor here. Let's see how this one measures up. It will fit if I clamp this. Now I'm sorry that it's zoomed in. I'm trying to actually get it so that you can see the screen without the glare of the lights on the bench sort of affecting it too much. If I clamp that in, oh, get in there, clamp that in. There we go. And again, it says it's a resistor of 8.384K, so 8,300. It should be 82K, or sorry, yeah, 8.2K. So it's not far out for again, for a 10% resistor that's got to be getting on for 40 years old. So that's that. Now we tried those capacitors. Let's try a modern capacitor in the very low picofarad range, and again we'll just clip that in. It's going to start for me. Right, 307 nanofarads, which and it gives you an ESR of 0.74 ohms. So it's got a lot of information on that particular capacitor. It's a 3.3, so it should be 3.3 with 4 zeros. So yeah, what did we measure at? Brain's gone dead. There we go, 306. It should be about 330 nanofarads, but yeah, again within the tolerance of that. Now the ultimate test is obviously transistors, and I have, let's move that across a bit, I have a box of new components here. So let's try various transistors and see what they come up with. That's assuming I'm putting them in the right slots. Now that's showing a pair of diodes, which is not quite what I expected. That is actually a, I can't even read the writing on it without my magnifying glass. That's a voltage regulator, 7812 voltage regulator. So let's try a standard tip 42 transistor. And that's saying it's a diode. Transistor. If you hold it in the menu, obviously you get various other options. There we go. Better. Told it it's a transistor now. And there you go. It's showing that it's a PNP transistor, and it has an HFE of 148. The current going on the emitter is 6.4 milliamps. UBE, yeah, it's just showing, and it also shows which pins are which. So one is the emitter, and just try to show that again. There you go. One is emitter, two is collector, three is base. Now that matches up to the 1, 2 and 3 on here. So you've got emitter, collector, which is also connected to the tab, and pin 3 is the base on this particular transistor. So let's keep that in the shot there. Let's put that one back. Where did I get that one from? I shall sort that out in a minute. Tip 42 is over here. Let's try one of these smaller 7805 regulators, and again yeah, this I think should come up as a pair of diodes because it's a regulator as opposed to a transistor. And we'll just spread the legs over the 3 pins there and give it a go. It says part unknown or damaged. Okay. Doesn't seem to like that one. Let's try it in the other set of sockets and see if it likes it that way round. There you go. I had it in the wrong sockets. So it shows it again as a pair of diodes. Shows that they're both working. Obviously it can't act as a full voltage regulator because it's got nothing to regulate against. BF284, this should just be a standard transistor, so if I spread the legs on that, and we go 1, 2 and 3. I'll fire that one up. Oh, it says it's a capacitor. Why does it say it's a capacitor? Probably because I've again put the leads in the wrong place. There you go. It's actually an NJ-FET. So again, N-junction J-FET, and it shows you your drain, gate and source. Yeah. So as a component tester, once you get the hang of putting things in the right sockets, it works perfectly well. LM340, that's another voltage regulator. Let's just try one more of these transistors. Oh no, that one, the leads aren't bent enough. It won't identify components, it will just test the characteristics of the components that you have. So again, let's try that, see if I've got a good enough connection on all the contacts. There you go, an NPN transistor, and again it's showing you the emitter, collector and base being the way the pins are. So you got emitter, collector in the centre, base. So that's just a few of the basic functions. So we've run through a couple of resistors, couple of transistors, capacitors, and yeah, it does have so many other functions. You can actually plug in on this one and get an oscilloscope square wave out on these ports here. You can also, if I remember rightly, it's square wave there as well. You can measure frequency and voltage from the other terminals. There is an online manual. I've yet to look it up, I'll be honest. You can even test surface mount components on these 3 pads. These 3 pads equate to 3 sockets on here. So in fact, if you wanted to test this capacitor, as long as you could hold it on the pads, I should be able to get a reading. Of 310 nanofarads. So you get the idea. You can test surface mount components on this. If I take that off again, it will say no component. So there we go. That's the little component tester. Well worth building up for the money, and it has so many other attachments in it that you could use it pretty much as a de facto go-to test meter for your projects. The only disappointing thing about it is the fact that the screen is exposed. I would have liked to have seen the screen behind some acrylic, because I find that might be too easy to damage. But apart from that, no complaints about it whatsoever. Obviously with the bench here you do get a lot of reflection on the acrylic, but when I'd use it, I'd actually be sort of standing it up like that, so that I could see the display directly as I was looking at it, and it does pretty much exactly what I want it to do. I'm running it from the power supply rather than the battery. If you want to run it directly from a battery, then there's nothing stopping you. So yeah, there we go, the end of that little project. thanks very much for watching, and I hope it's been interesting, and we shall see you all soon. Thanks very much. Bye bye.